30-3s, good day, and welcome to a new unit. We're on Unit 5, Trigonometry. Trigonometry, not something that's new to you, stuff you've seen in the past. And we just finished up the probability stuff. So Trig has some review, which hopefully won't be overly complicated, but it also is going to add some math that's very calculator based. So you need a good calculator. But at the same time, besides being calculator based, it's nice because it's very procedural, but you have to think in your setups. First couple lessons, though, will be fairly straightforward. Because what trigonometry is basically dealing with sides and angles in shapes. Now, what we've dealt with mostly with trig is that we have dealt with right triangles up to this point. So our trigonometry has been all about right angled triangles, meaning it doesn't matter what direction the triangle is facing. Every triangle we've dealt with has had a 90-degree angle in it. So we've been working with these over the last couple of years, going back to junior high even. There was work with right angle triangles. What we're going to get into later on in the unit is non-right triangles and being able to come up with side and angle for triangles that don't have a 90-degree angle, where there's not a true perpendicular angle in it anywhere, and we're going to work with those triangles. But before we get to those triangles, we will be focusing on the right triangle geometry. So right triangle geometry actually goes back to junior high. You were first introduced to it, so we're going to do a little review and ease into it. Big thing with right triangle geometry is the fact that you have to have a 90-degree angle, which is shown with the little squares in the corner. That way we know it's 90 degrees. It's a right triangle. The other thing that's important with right triangle geometry is the fact of the labeling. Sides are always labeled lowercase, whereas angles are always labeled with an uppercase letter. But besides that, the other part that is important for some questions that we get to is the fact that opposite angles and sides are labeled the same. So this is going to be important when you get questions where maybe you have to create the actual shape instead of just doing the work with one. So if we take a look at the two triangles that are on page 2, and I said finish labeling what's there. Well, can you label the unknown sides and the unknown angles correctly? And correctly means using the correct variable in the correct form. Well, we have angle A and we have angle C. So opposite angles and sides are labeled the same. So that means if this is angle A, across or opposite angle A is a side. And there's the side that's opposite angle A. Well, opposite angles and sides are labeled the same, so this is side A because it's opposite angle A, but remember, sides are labeled lowercase. Now again, same kind of process. We have angle C here. There's angle C, and across from angle C is side C. So angle C, across from it is side C, but we label it with lowercase c because sides are always labeled lowercase. That leaves us with side B, labeled lowercase because B represents the side, but what's opposite or across from side B? Well, that would be angle B. So there's the correct labeling for that triangle. C has to be that side because it's across from angle C. A has to be that side because it's across from angle A. And angle B has to be across from side B. So that's the labeling you have to have. And just really quickly, while this arrow points at this, why is that a special side? In this case, C is your hypotenuse. Hypotenuse is the longest side or the side across from the 90. So can you take a second and label the second triangle that's there, labeling it appropriately? So here we go. Here is angle F. Well, across from angle F would be side F, and we label it lowercase. Here is side E. And E, the side, is across from that angle. So this angle across from side E would be angle E, but we label it capital. Well, that leaves one more angle, and we have side D, so that would have to be angle D, but it makes sense because angle D is opposite side D. So that has to be the labeling we have. Now, question is, what's the hypotenuse? Well, the hypotenuse is across from the 90, so if that's angle D, across from angle D would be side D. So in this case, side D is the hypotenuse. So a little bit of background information, some terminology we're going to use throughout this particular unit. So now we get the Pythagorean theorem. Pythagorean theorem is one that you've seen before, and what is Pythagorean theorem used for? It's to solve for an unknown side. But when do we use it? We can find an unknown side when two sides are known. So this only works if we're working with sides and not angles. And there's the formula. You've seen it before. Most students kind of like Pythagoras because it's not too complicated. I hope that's true. The only thing in the general Pythagoras formula is you always have to equal the hypotenuse. So the longest side across from the 90 in this case is C. This has to be labeled C because it's the longest side. And across from side C would be angle C. The other two sides are A and B. They don't matter which is which. Across from side A would be angle A. Across from side B would be angle B. So there would be our labeling. A and B are interchangeable, but this must be C because in our formula, it always equals the hypotenuse when we're adding the sides. Now, some of you might, and this isn't in the booklet, but you should probably add it. If we had a question where the hypotenuse was given, and maybe side A was given, well, there's an unknown. We don't know what side B is. Well, this formula, a squared plus b squared equals c squared, it's a good formula because we can plug in a and b to get c. Well, another way is manipulating that formula. If we don't know what b is, we can take the hypotenuse and square it, take the other known side and square it, and that will equal the unknown side squared. So it's just another take on the Pythagoras formula. The first formula gets used. Whoops, didn't want that. Sorry about that. Big sausage fingers, bang something wrong. In this case, this formula gets used for solving for the hypotenuse. So that's the formula if we're trying to calculate the hypotenuse, whereas this formula we use if we are given the hypotenuse. Just a small little change in the formula that makes our calculations nice and easy. So that's Pythagoras. Let's practice with it a couple times. Here's a question. It wants us to find side E. Well, side E is across from angle E. So there's the side we're trying to find. And which side is it? Well, it is across from the 90. It is the longest side. So that's our hypotenuse. If it helps you, instead of calling it E, make sure you identify it as C, because that's the hypotenuse in Pythagoras' theorem. Side D here, well, if it helps, you could think of that as A, and side F, we could think of that as B. If that helps to make sure you're using the correct values in the Pythagoras formula. Some of you just understand how it works, depends upon the individual. But at this point, our two non-hypotenuse sides, 4 and 6.5. 4 squared plus 6.5 squared will equal the unknown hypotenuse squared. What can we do once we substitute it in? Well, we can do our multiplying. 16 plus 42.25 equals C squared. What could I do to get C by itself? Well, I could add what I have here. We get 58.25. That equals C squared. And here's where I find students make the biggest mistake. They leave that as their answer. That's not the answer, because this is what C squared equals. We want to know just what C is. You always finish Pythagoras, always square root to finish a Pythagoras question or calculation. Always have to finish with that. Otherwise, we're going to have the wrong answer. So I now need to square root that, and round to the 10th place is always safe. C is equal to 7.6. So, does 7.6 make sense? It does, because it's similar to our other values, and we did calculate the hypotenuse, which is the longest side. Our calculation was the longest side compared to the other two, so it makes sense that the hypotenuse calculation is correct. There you go. Give the next one on page 2 a try, and then we'll talk. Give it a whirl on your own first. So again, at this point, we have side X, we have side Y, and we have side Z. If it helps you, only if it helps you, we're trying to find across from the 90, so we're trying to find hypotenuse, which means the other two sides could be identified as A and B if that helps you, because we're trying to find the longest side, the hypotenuse. So we're going to have 12 squared plus 5 squared equal to C squared. 144 plus 25 equals C squared. Well, I see I can combine those. I can get 169 equals C squared. But like we talked about, we always finish Pythagoras. We don't want to know what C squared equals. We want to know what C equals. So we always square root. And C is equal to 13. So when we put the 13 into our diagram, again, we calculated the longest side, and our calculation is the biggest one, which it should be. We might have made a small error in our calculation, but at least it makes sense. Because we calculated for the longest side, at least we got a length that is the longest side, so we're on the right track. So if we go to the next page, page 3, we have 2 more examples. This first one, there's your diagram, and it asks, what's the horizontal length of the ramp? Well, horizontal is left and right, so we want to know, we know the ramp itself is 4.1, whether that's feet, meters, who knows, and we know it's 0.9 high. We want to know how long, how much left-right distance does the ramp take up? Well, I hope the first thing you recognize in this question is that we now have the hypotenuse given to us. This time, the hypotenuse, the longest side, is known. So based on what we talked about, start of this lesson, if we know the hypotenuse, we can change up our formula to do a little bit variation of Pythagoras, which allows us to solve when the hypotenuse is given. So because it's given, we're going to use a little bit different formula. A and B are interchangeable. Here, I've labeled the unknown as B, what we're trying to find, so that would be A. So using this formula, I can plug in. Now I have the 4.1 squared. Subtract the other known side, 0.9 squared will equal the unknown side squared. Same kind of calculations. Know the formula, use it. 4.1 squared gives us 15.6. Whoops, sorry, my bad. 4.1 squared subtract 0.9 squared. If you do these calculations, you actually end up with 16 as a value equal to b squared. So the 4.1, if you wanted to show all the steps, the 4.1 squared is going to give you a value of 16.81. So this would have been 16.81 minus the 0.9, which would be a value of decimal 81, which leaves us with 16. But that's b squared. Always finish by square rooting. So b equals 4. And b equals 4, if I put that into my sketch, it's not drawn perfectly to scale, but we see that what we've solved for is shorter than the hypotenuse, which it should be. 4.1 should be the longest side, and it's a little bit longer than another side. Give the second one a try. Sorry, it's the same one. There we go. Give this second one a try. Side N. We want to know what side N is. Well, this is not a good diagram at all. Oh, yes, it is, but I've labeled it wrong. Sorry about that, because it asks for side N. Well, across from angle N would be side N. So technically, when I typed this up, I did it wrong. In your booklet, it's correct in the sense that this is actually angle M. This is angle N. I apologize for my mistake. So if we want side N, here's angle N. So across from angle N, there's the side we're trying to find. Across from angle M will be side M. And why is 15.6 important? Because that's across from the 90. So there's your hypotenuse. So that's what we should be using for C in the generic Pythagoras formula. A and B are interchangeable. I'm going to use that as A, and that is B, because those are the variables for the formula. So C squared, 15.6 squared, minus the A squared, which we know to be 5.9 squared, will equal B squared, which is what we're trying to find. So if you punch this into your calculator, you're going to get 15.6 squared to be 243.36. Subtract the 5.9 squared. When you punch into your calculator, you get 34.81 equal to b squared. And what's nice with this formula, we just do what it says, which is to subtract those two things. We get 208.55 equal to b squared, but always finish with your square root. And when we square root that, round to one decimal place, 14.4 is the length of B. So again, let's take a look. We're now saying that 14.4 is B, or N in this case. Why do I like that answer? Because there's our hypotenuse at 15.6. We've calculated one of the shorter sides, and it is shorter. And that's what's important. So there's Pythagoras, a nice, easy way to work into the trig unit because it's review, please finish page 3 and then do page 4 and 5. The new booklets are posted. Check your answers there, and that's what I'm referring to. Have a great day.